Sustainable septic choices for a tiny house depend on measuring energy footprints, nutrient outputs, reuse potential, embodied carbon, and maintenance burden. Assess aerobic treatment units versus passive systems by calculating their lifetime energy consumption and treatment efficiency. Aerobic units use electricity for aeration, so estimate annual kilowatt hours based on rated power and duty cycle and compare that to grid emissions or your renewable supply. For passive systems like sand filters, constructed wetlands, and composting toilets, quantify performance by looking at removal rates for total nitrogen and biochemical oxygen demand and match that to the sensitivity of nearby surface or groundwater receptors. Include embodied carbon for tanks, piping, and media by multiplying material masses by typical carbon intensity factors found in published lifecycle inventories, and add transport distances to capture freight emissions. Consider water reuse potential by measuring effluent quality against simple irrigation or non-potable reuse thresholds, and plan disinfection steps only if necessary to meet reuse targets. Finally, rank options by lifecycle resource intensity using a simple scorecard that weights energy use, nutrient discharge, embodied carbon, and maintenance time, so you can choose the lowest impact solution for your site goals. Common mistakes are choosing a high-energy aerobic unit without checking reliable renewable power options, which leads to hidden operating emissions. Mitigate this by either sizing for low-wattage models, adding battery-backed solar-sized for annual kilowatt hours, or selecting passive treatment instead. Another issue is underestimating nutrient loads when you plan for small dispersal areas or sensitive receptors, so run a simple mass balance using expected daily wastewater volumes and typical concentration ranges, and upsize dispersal or add a polishing step if loads exceed local thresholds. A third problem is ignoring embodied carbon from synthetic media and concrete tanks, which can make a low-energy system still high impact. Reduce this by prioritizing recycled content, timber or earthen alternatives where appropriate, and minimizing transport distances for heavy components. We run bighomeprojects.com to help homeowners compare system options and connect with local contractors who can provide quotes and installation details. Our site also hosts a discussion community where we share case studies, installation tips, and maintenance experiences so we can learn from one another.